Dope.
Ooh, okay. So the hardware hacking one?
I really like that one. Just FYI.
All right. I think we don't have the hardware hacking one. Is that it?
I'm going to drink and...
Oh, hi, I didn't see you there. My name is Joe Grand, also known as Kingpin, just doing some soldering, getting ready for Colonel Con Hack Live. It's gonna be so fun.
Sick.
I love those videos. They're my favorite thing here.
They're so good.
Okay, so we're gonna bring Tyler, and we're gonna also bring Joe into the screen. Hi, everyone. Welcome.
Joe and Tyler, you're both muted, just FYI. But Tyler,
Let's go in.
And Joe, can we hear you still?
You're still muted.
You have to, you have to unmute yourself here on StreamYard.
In StreamYard.
Working it.
Oh, no.
Here we go.
Yeah.
What's up?
Got him.
Lead hacker.
The internal mic, so we can switch that around later. Hi. Oh my God. Am I echoing to you?
Yes.
It's uploading through space. Can you add my other, the GoPro?
Which one? You have two.
Yeah.
One of those is hooked up to his good mic.
Check one. Check. How's that?
Oh,
Yeah.
yes, that's so good. Yes.
You did it.
Wow. That I know Chris was nervous before starting his after watching the first two, but now after watching his also, I don't know. This is gonna be crazy.
You got it, man.
It's gonna be great.
Oh, you got it.
Awesome.
All right.
Shall we do it, or is that
I read your should I read your
I got it.
Should I have the others? Okay.
So
Yeah.
a couple of housekeeping things to hit first. One, thank you and shout out to Joe Fitz. He helped kind of brainstorm a couple things and do a little tabletop with us to make sure it was ready for Joe Grand. So that's number one. Number two, you're going to find some PCBs, and you're going to find them in like 3D printed cases. And in an effort to make the challenge as succinct and educational as possible, only the traces and the wires and the components that are exposed are in scope. Just so that we can put you in unique situations. Otherwise, you would probably use the same thing over and over again, right?
Okay. I'm not going to remember that anyway, but you can remind me as I'm doing it.
It's in a case. Just don't open the case.
Don't take the case apart.
That's the best part, is opening the case.
No cases.
Okay.
So that's it. Those are the two things. Hopefully the audience and yourself will appreciate why we put the hacker in the box a little bit, but got to do what you got to do. So I'm going to roll a dice, which will determine which prompt you get. D&D style here. All right, I rolled a 13, which is a good prompt.
Yeah, lucky 13.
All right, so you are one of the universe's greatest hackers. You awake aboard a foreign spaceship on a desolate, distant planet. Your best chance of survival is to leave the planet using the spaceship's autonomous flight. However, the ship needs some work before the computer can launch it. You find several of the ship's systems are destroyed. Luckily, it would seem fate is on your side. You found a box full of spare parts and systems. There was a note on the box that said, "Remember to check the logs." You must get the spaceship working. Your survival depends on it.
Okay.
So you have a box that has primary written on it.
Yep.
You can go ahead and open that.
Okay. Should I leave secondary as it is?
Yep. That's
all right.
Hopefully we won't need it.
And
okay.
Joe, just out of curiosity, did you write down the part about you being the universe's greatest hacker? That seems like a really important part.
Right. Quote the next TV show.
All right. Can you guys see this view?
We can. Perfect.
Okay.
So you're going to find some manila folders like
Chris did.
That Chris did. Just set those aside.
Okay.
Everything else, you are free to open.
All right. Packing material.
You can open it. You can pop them and do whatever.
There's a number P. Okay. So here are the
letters. So you can. The numbered ones set aside. The lettered ones you can use. Those
are
are
off
which
to the
we
side. All right, so we have P, F, D, A. I love those other challenges too. It just showed the reality of actually hacking compared to like when you see a final presentation on stage where all the hard work has been done for sometimes, months, if not more, all that dirty work. And I don't know what to expect. All right. So, I see. Okay. So there's.
So you should have A through G.
Okay. There's a 5, and then there's
numbered
A,
ones
B.
can get set aside.
A, B, C, D, E, F, G. So 5 and P put aside.
Yeah, what's up with P? Is that like a D lowercase or?
No, because I have an uppercase D also.
Oh.
I don't know
Is
what that is.
D flat? Well, then you're allowed to open it, I think, right?
It feels like it's
open whenever.
like some sort of bottle, like a water bottle or something.
Oh, okay. Set that aside. I know what that is.
All right, setting that aside. I'm getting rid of the bubbles,
Yeah.
getting those off the desk.
You said he could open them.
So yeah,
All
go
right,
ahead and open A, B, C, D, E, F, G. Are totally fair game to open.
I can open all. Okay.
Yes.
All right. I'm doing it.
Tim is saying in the backstage that Pete can open whenever when he runs out of pizza.
Okay.
Oh, I already ran out of pizza. Yeah, by the way, thank you for the pizza. It showed up an hour early for those who are wondering why I'm not eating it now. So I got to eat it while watching Chris hack on stuff, which was amazing. And now I'm fully caffeinated and fed. And being caffeinated probably is not good for soldering and doing stuff that I'm expecting to do, but it'll be more entertaining for you.
Or
right,
maybe
so-
it means that you're going to solve the challenge faster than we expected.
Well, maybe. Okay, this is some sort of fuel module. I see. Looks like there's probably is that a mini Arduino, mini Arduino Mini Pro or something like that, controlling LEDs. And I'm only allowed to touch this stuff, so this is probably some interchip communication protocol, I2C or UART or something to send data to these to turn on these things. That's just my guess because I see 2 wires and then power and ground because you got to have power to the thing and you got to have ground, which is your 0-volt reference. So just a guess. I'll probably have to analyze that, I'm guessing, or figure out what that protocol is,
And
knowing the devious nature of.
Joe, which package did that come out of?
Oh shoot.
That doesn't really matter.
Oh, that
Okay,
was package C.
All right.
This one is G. I'm doing them out of order.
That's totally fine. We had them numbers just in case we needed to release them in some order, but we don't, so we're good.
Oh, okay. This is a power distribution module. Looks like it has some ICs. I don't know. They're transistors or logic gates or something. Also 2 wires and 2 wires. So maybe all of this stuff is going to be on a shared bus, and then I got to figure out, oh, look, a schematic for that thing. Yeah, it's a bunch of 74LZ1. I got to look up what that is, but it looks like in some sort of AND or some 2-input logic gate thing. So, all right.
Don't lose that. That's important.
I won't lose that. It's laminated, so it has to be important. This is a little F, uppercase F, but it's really little. All right, is this an okay view? Can you, because I can't really adjust the tripod too much, but is this suitable?
Oh, that's
look at
perfect.
that.
Yes, it is. Just
amazing.
with the other cam, we can only see your back. There you go. Now
Yeah.
you're smiling at the
So
other
that
cam.
iPad one, when I move I'm going to end up moving everything from this workbench over to where I have my oscilloscope and power supply and stuff over here.
Mhm.
I just figured to get everything set up in case I have to do some soldering and stuff, I'll do it here. Okay, so this one is a memory module, very clever, covered in epoxy. Reminds me of the hard work hacking class that I teach has a memory module covered in epoxy. And this one is actually an 8-pin dip. You can see it's a pretty large package. So if I have to scrape anything off of there, I can. But it looks like there's exposed test points also to connect up to that. And it's broken. Very cool. Like somebody cracked it open, didn't want me to get home. All right, letter D. I bet you didn't think hardware hacking involved opening so many bags, did you?
My garbage can in my office likes to beg to differ. It is full of so many bags and stuff.
This reminds me of like a super high-tech version of snap circuits or something. Okay, so engine temperature module. So it must be a temperature sensor and a display And again, these 2-wire things. So all this stuff is probably going to connect to some main device. Open the wrong side. Oh, wow, this one was sealed on the wrong side, but I got it out. This is number B, oxygen supply module. OxyFlow, okay, there's an LED in there and another little Arduino Mini or something. Maybe there's an actual oxygen sensor in there, but it doesn't look like it. So maybe we have to send the right data to this thing to tell it that the oxygen is okay.
This is such an unboxing moment. Y'all such influencers.
Launch control module. Okay, this one has a power supply attached to it. There is a series of 2-pin headers here to connect all of these different modules to. And then there's a console, a UART interface. So typical 4-pin UART interface, VCC, which is voltage, TX, RX, and ground. And there are some like weird jumper solder blobs on there. So maybe that has something to do with it. Like if the traces have been cut or something. Inside looks like, I don't know, more Arduinos or something. But I'm not allowed to look in there, so I won't. Number E, letter E, last one. Open the wrong side of this one too.
Those are flags, by the way. You get credit for opening the wrong side and then still getting access to the contents.
Okay, communications module. This is a 555 timer, which is like a kind of can generate different types of clocks and act as triggers and take inputs and stuff. A very kind of ubiquitous device, analog electronic device, one of the best. So looks like, yeah, there's resistors and capacitors. That's going to set the timing. So 10 hertz signal. So maybe I'm going to have to tweak that to get the correct square wave out of that. And then it's going to tell me if the frequency is okay. I'm guessing. I don't know. Okay. So that clue was to check the logs. So I'm going to do that. Actually, I'm just going to unpack all this stuff first. So I see another 555 headers, a bunch of different valued capacitors and LEDs and stuff and wires, which I may or may not use, may or may not need. I also have all of those things. I don't know if you can see them, but can you see? Yeah, all of those boxes up there full of components. All right, I'm just going to open this up, throw the bag away, extra parts. All right, so I'm going to plug in this launch control module. I'm going to go back over here, and I'm going to switch my camera view also so you can see what I'm doing.
We're taking a trip, everybody. Buckle your
Yeah, here we go. Here we go.
Yeehaw!
All right.
What a ride.
I'm using sort of low-tech GoPro setup here, but it works. Actually, I think I need to change my... that'll be good. A little glitchy. I'm running all of this on a single MacBook, old 2014 MacBook Pro, so it's a little bit glitchy. Okay, so this is like where I normally do a lot of my work that doesn't require soldering and stuff. So I have an oscilloscope here. What I'm going to do is, with this UART interface, it's a super common type of interface on systems to give you like boot log information or an error log or whatever, root shell sometimes on systems. So, and a lot of times with systems, you're going to see that on power up. When the system boots, it's going to send some data. There might be other situations where it's going to send data later. When there's a transmit and receive, it means it's going to send data out and probably receive data back from us. But what I'm going to do first is just use my oscilloscope, see if I can figure out which signals do what. And then I'll attach probably like a USB to serial adapter, which I happen to not have out, but I can get one out. I think I also, well, let me see. This is 3.3 volts. It's a little too short to reach to where I need to go. So I'm going to unscrew the power supply and just power it from my benchtop supply. I don't have an extension cord. These are like little screw terminals on here, so take these off. I'm assuming power and ground are not switched on me because that would be mean, but I'm going to test that. So I took this out. I think this one with the white is positive 3.3, but just to be sure, because you don't want to power something in reverse and have it break. So So
That's a safe assumption to make.
Is it? Okay, so I won't do that. All right.
I'm not mean. The colors are right.
What's that?
So the colors are right.
Colors are right. Okay. So I'm not going to go and do that. That would be mean. All right. So I'm going to get 2 more wires. Just as
But if you did, there's a backup, so you can fry it.
Yeah. Okay.
We found
cool.
2 boxes of stuff.
So I'm actually going to use some of these. Those are kind of like. What do I have for good wire? All right. I'm just going to strip some wire over here. I know you can't see it, but trust me, I'm stripping wire. I'm just going to make little add-ons just so I can clip on easier to those terminals. Here, I'll move over here so you can watch the wire stripping magic. There, look at that.
Ooh.
And I don't know if you can, yeah, so this is my bench supply here. That'll just save me the trouble. That will also actually probably make it easier to power on and power off as I'm, power cycling to see if there's anything coming out. I hope this is not too small for this little terminal block. If it is, I'm just going to cut the wires off on the other side. Okay, that should be good. Yeah, I can't see any, I have no chat or anything like that. So if you have questions or whatever.
Everybody's cheering for you.
Cheering, you can do it. Okay, so let me see. I'm going to check the voltage on this before I actually attach it. So adjust that to 3.3 because that's what the wall wart said, which is also fairly typical voltage for most, or a lot of systems, not all of them. Okay, so I have ground power. All right, so get this on. I'm not going to power it up quite yet because I have my scope. The oscilloscope is one of my favorite tools. It lets you visually see signals and how they change over time. So it's something where you can use a logic analyzer as well. It just happens that I have my scope here. I do have a logic analyzer as a backup, which is my Salier Logic Pro 8. And there's a lot of open source logic analyzers and stuff you can use as well, which will let you see digital data, where the oscilloscope lets you see analog measurements and also digital, of course. And then there's some overlap. You can like decode data with the oscilloscope, which is probably what I'm going to do, I'm guessing. Okay, so the screen is a little bit dirty, sorry. So can you, yeah, so you can't really see it totally well, but that's okay. I'll kind of run through it.
You're good, yeah.
Okay. All right, so I'm going to connect my ground probe, which I don't actually know if that's working yet. So let me just use my multimeter. This is sort of like what Chris was doing, where he's like labeling stuff and kind of understanding the basic flow before jumping into it. So if, just will hopefully make things easier later. So I'm going to check ground and make sure the ground pin that I'm connecting to on the console goes somewhere.
Trust but verify.
Trust but verify. So it goes to a bunch of connections. It doesn't go to those 2-pin headers at all, which is interesting. VCC goes to the right places too, doesn't go to those headers. So, oh, right, because we have, all those solder pads must be to solder on the red and blue wire, or the red and black wires from the modules, and then that's going to be our communication. That's probably why there's like some solder blobs there, and there's 1, 2, 3, 4, 5 or something. And how many modules do we have? 1, 2, 3, 4, 5. Okay, yeah, so that makes sense. We'll probably have to solder those. So I might be going back and forth a bunch. All right, so I'm going to power this up. Let's see, how am I going to do this? All right, I'll just clip on here. It does say TX and RX on here, so transmit and receive. I'm just going to hook up to TX first, and then just make sure my scope is set up. I have a whole bunch of other stuff on here that we don't need. Turn off my label because that's not what we're looking at.
Why did they pick TX and RX? They're right next to each other on the keyboard. I mean, it's so prone for typo errors.
Well, the thing is,
I'm kidding.
Well, it also doesn't matter, right? Because if we're looking at the signals, it doesn't matter what the labels say, because we'll actually see if it's transmitting or not. If it's not, we can flip it around. And a lot of times too, depending on what the engineer puts, is it transmit from the target side or is it transmit from the computer side? So it's always a mess. There's no like defined standard.
You just try everything until it works.
You try everything until it works. And the beauty with UART is if it's being transmitted, if you're not able to decode it, or you're not able to see it, if you don't have an oscilloscope, you're just using a USB to serial adapter, you just switch the wires, right, and see if it's going to work. All right, so I'm going to, I have this running. I'm just letting it run kind of free running, and we should see something on the screen, maybe, and then we can kind of narrow down from there. right, so this one is active high. Okay, so we do see data on that one, and that's TX. So I would assume that TX is just TX. Let me run it one more time on RX. And RX is going to be idle high, and you see a little bit of noise on there when the transmit side was transmitting. So yeah, this is going to be the RX side that we'll connect up to when we're ready. Now, the thing with UART data is it's asynchronous, meaning there's no additional clock line needed for the data. So as we turn this on, the speed of the signal is actually built into the signal itself. So let me set up my trigger so we can actually stop on it, and you'll see what I mean. I gotta set this, yeah, active low. Okay, so now I'm gonna power this up. And we see a bunch of data here. If you look at enough data, you'll be like, oh, that looks like asynchronous data. Sort of like with Chris, it's like, oh, that looks like RC4 or whatever. So this looks like asynchronous data. And
I think you did something, and you completely broke your transmission quality.
Oh, look how glitchy it is. That's probably just my
Yeah.
computer.
Yeah.
Yeah, the GoPro's having a little bit of trouble.
Yeah, okay. Well, here, why don't we just, you don't need to see me, really. Let me put the iPad on the screen thing, and then we'll just kind of make do. I'll kind of do it like that.
I love it.
Something. I don't know, something like that. You can choose. I need to prop it up on something too, so I'll do like, let me get a binder. This is real hacking.
I know, this is how's
Get the camera working. Normally,
the CTF,
nobody-
the CTF has, you know, like a set of flags, but really there's like the whole like alternate reality subset of flags. It's like solving how to get to fixing the set of flags.
Yeah, well, normally when I'm hacking on stuff, like I'll film some of the tests and stuff, but I don't really, you know, constantly film, so I don't really have a great setup for it. Okay, maybe I'll just try to do it like this. So, oh Jesus, let's see.
Back in Brazil, we have a really nice term, kind of a slang. We say gambiarra.
I love
What
it.
that means is you make something out of whatever you have. You make something work with whatever you have in hands. So you take advantage of whatever resources you have to make something work, kinda-ish.
This is what happened when we were testing. Remember, it was like working and then it wasn't. So,
And
okay,
that's just one word.
I'm gonna hold it for now because we're not gonna do this forever. So we see some data on the screen here, and yeah, like I said, if you've looked at enough asynchronous data, it looks like asynchronous data because there's no additional clock. Like with synchronous data, you'd find some clock somewhere and it would synchronize to the bits. This is like a repeating multiple of this smaller bit width. So that just kind of tells me that what it's saying on this module is right, TX and RX and UART. So I'm going to zoom in and take a measurement of the narrowest bit time. And this is basically going to tell me the time it's taking for the system to send one bit. And then I can convert the baud rate and then connect up to my computer and stop holding this camera. So I'm going to measure the bit width, which is 106 microseconds. So it looks like here it's 9.43 kilohertz. So that would convert close enough to 9600 baud, which is a standard baud rate. Sorry, I'm not totally on it. Yeah, so standard baud rate, 9600 baud, kind of slow, but normally a lot of times you see like 115.2 kilobits a second or something. Okay, so now we see the data there. So I'm going to put this back on the thing. No, I'm going to put it back on this thing so I can actually type on my computer. And I'll hold up what I'm doing before I plug it in. And you might still be able to see it on the GoPro. So I need to get a USB to serial adapter. You could use some other tools as well. But this is a device. Where did I put them here? This is a device that will take the logic level signals from the from this target board. Like we saw, these are 0 to 3.3 volt signals, and convert it to a virtual COM port that we can then use our computer to actually communicate to that console. And let's see. So I'm using a FTDI Friend. It's an FT232 based device. You get them on Adafruit, but there's so many other ones too that you can use. And let's see, because that is the socketed side, I need the pin side. unless these line up. No, they don't. Okay, so I'm going to disconnect my scope. I'm going to get some header pins from over here. Hopefully I have long enough header pins. I don't actually know where my other header pins went. I could solder wires too. Okay, I found header pins. So I'm going to use these header pins, just stick this thing in here. So now I've extended the headers, and now I'm just going to use regular like plug-in wires to make that connection. That way I know it's going to work, or at least I know the connection's going to work. I don't know if the system's going to work. So I'll get my wires.
You're being applauded for your level of organization.
Got them in a bag. Well, it's funny. I always tell people, you know, I grew up as a hacker and I've been doing this stuff literally my entire life, but I'm also an engineer. So I have like that very rigid engineering mindset, but then also the mischievous hacker side. So thank you. I'm glad you appreciate my organization because nobody else in my family does. Okay, so I'm going to hook up this USB serial adapter. I have TX-RX and ground. I don't need power for this module because this is going to be powered directly from the USB port. Oh, I need a micro USB cable also. So BRB.
Going to the micro USB cable drawer.
Going to my cable. I have a little cable kind of holder over, well, kind of on the wall over here. Here, I'll show you. I have a camera. I can do this. So it's over there. Cables.
Oh my gosh, that's amazing. Mine are all in like labeled bags. Like these are the micro USB cables. These are the USB-C cables. These are the
I also have a massive
cables.
I have a massive box of everything else, but those are the ones that I use all the time.
Yeah, that's where I'm at. I have a drawer full of rat's nest of stuff.
Ugh.
I'm gonna plug in. How does that GoPro look now? Did it catch up at all? Like
it's still
pretty laggy.
It's still yeah.
It's not
too bad.
terrible. If you're narrating and stuff, you'll probably be all right.
Yeah. Okay. Well, I'm gonna just plug in the USB to serial adapter. So I have ground that needs to go to ground. I have the transmit from the target. Really is the transmit from the target. So that's going to go to the receive pin of this, which is orange. And then the receive is going to be the transmit from the adapter, and that's red. Okay. So now I can load up a terminal program. I usually don't use PuTTY. I usually use like CoolTerm or something, but I don't know if they're adding any sort of like, you know, colorized things, or I need a good terminal program. So I'll just use PuTTY, but I got to see what, and you can share my screen too if you want, if you still see it.
Yep, we got you.
Oh
okay,
yeah,
cool.
awesome.
So I'm going to look and see my USB to serial adapter is here.
I think you got muted somehow, Joe.
Oh yeah, sorry. Your iPad looks muted.
I think his audio is coming from that GoPro, right?
Yeah. The audio is
right.
coming
Okay,
from the GoPro. That way I'm on a wireless thing and I can move around. Okay, so I'm running PuTTY, which is one of many terminal programs. I just don't see it on the screen. So I don't know where it's going to pop up, and I'm hoping we don't see all sorts of other personal information. So let's use screen. So screen, is it the baud rate first or the port first? I don't remember. No. Okay, is it screen that? Okay, so that's 96. Okay, so I can, oh, look at that. All right, there's a typo, uncone command. So I'm in screen and super simple terminal program. So I'm in some command system, but I want to see the whole thing from power up. So let's just power cycle it once. And we are at 9600 confirmed. So we'll power this up. Nice ASCII art. I love it. Launch control module version 1.3.37. Very good. Module status report. Return last log of modules. Launches vessel if all modules are active. Okay, so maybe I'll do status report first. I can type. So I'm typing from my computer to this thing. Nothing's connected. Manual mode for memory. Okay, so I assume we'll have to do the log to see what's going on, and then we'll do status report to make sure everything is connected, and then we will launch. And if we launch with all the stuff, then we win. Launches vessel. Maybe.
So maybe. Awesome. This is
I don't know if that's right. Launches
sounds
vessel.
right.
It sounds right. I'm not even gonna run launch. I don't even want to try to do that until things are connected because I don't know what that's gonna do. So let's read the log because that was the actual first clue. So there's communication, memory, engine temp, fuel, power, distro option. Okay. Radios are down, base oscillation error. It needs to be 10 hertz. I just had the intern fix it. Okay, God. Well, let's just do that one first. That's like my least favorite. Is dealing with analog electronics, but we can look that stuff up. So we need to figure out what the frequency. Maybe do we care what the frequency currently is? No. Well, yes, we should see because we want to make sure it's a square wave and not some other like weird thing. So I'm going to use my scope again, and okay, so this is going to be power ground, and then we have to look at those 2 pins. So I might be able to. I need another set of header pins just to get everything set up so I can actually monitor those signals. Okay, I have more header pins. Yay. Yeah, all right. Yeah, let's just leave. Sorry about that. Let's just leave this camera going so I don't waste time because there's a lot of stuff it looks like needs to be done. All right, so I'm going to plug these 2 wires in because I don't know which one of them is. Oh, there's a signal there too. Okay, I might not even need that. Whatever. I'm going to, you know what? Let's read all of the logs and then I won't have to keep plugging stuff in. How's that? So that's module 1. Module 2, memory module. It's completely destroyed. We need to recover data and input using manual mode. Okay, so we'll manually retrieve data. We'll use like a device programmer for that, which I happen to have one here.
In the device programmer drawer.
In the device programmer drawer. This is temperature log. Engines can't prime without the proper heat. Something might be wrong in the sensing circuit. That last wormhole was flippy. Okay. You guys know I am horrible at puzzles, right? Oops, log.
I don't believe that. Sorry. You just lied to an internet full of people.
Yeah, you seem to be doing fine at this puzzle.
Okay, fuel log. Only receiving 1/4 of the fuel we should be. All right, that we'll look at that later. Power distro. This circuit was damaged beyond repair, so we recreated the board from the original schematic, which was attached to the module. We had a ground error and fix it, but it still doesn't work. Maybe we did something wrong. Okay, that's the thing with those gates on it. Oops. Log 6. No issues. Thank the maker. Oh, good. Geez, now we have 5 things that are bad. Well, let's verify that first. Let's take the oxygen
right.
sensor.
That sounds like something that someone would write who was low on oxygen and didn't realize that something was wrong.
Yeah, exactly. Totally fine. Trust me.
Everything's great. I feel amazing.
You know what I'm going to have to do is move. Okay, I'm going to disconnect this. I'm going to save time, I'm going to connect. Oh, I can't because I got to solder over there and I got to do this thing over here. Okay. Well, first I need to take a measurement of this of the 555. So I'm going to do that first. And then I think I'll just solder everything together. And then if I need to, I can unsolder it. But I'm going to connect everything up to that launch control module. So at least everything is powered. I just saw a light turn on and now no light. So let's see. Okay, there's a light. It may or may not be actually doing anything. But let's just probe it and see. It might need something from the control module. Okay, oh, so I do see a signal. This is just about a 10 kilohertz signal. No, that's not right. Let me do a quick measure. Looking at that. So it looks like we're about 100 hertz and we need to be at 10 hertz. So we need to divide that by 10. And oh man, I haven't looked at the 555 in so long. I guess I could Google it. I have a book on the 555, but why don't we just Google 555.
Does the book have a search function?
No, but I've used it so many times since I was a kid that I know kind of where it is.
You're like, it's probably around page 385, 387.
Oh, here, check this out. Clock output calculator. Maybe that will. Astable clock. Okay, cool. There's no such thing as cheating in hardware hacking.
Or any hacking.
Oh, this does look, by the way, it's a 50% duty cycle. Close enough. Okay, I want to do this in the opposite way. I want it to, oh, I see. I can just kind of mess around. Okay, well, the current values on here, R1 is, oh, they're five color bands. I can barely see those. Is it 110? Is it 110K? Maybe I can't really see it, but I might just measure it. I'll just measure it, whatever. Got turned it off first. I should be able to measure the resistance. It's not bright enough in my hacker layer for 5 color resistors.
But if it gets bright, doesn't that like exclude it from being a hacker layer? I thought like
Yeah,
hacker
that's right.
layers are supposed to be dark, you know.
So that's 8.2K and 68.2K. 8.2K, 68.2K, is that what I said? R1, R2. And then the capacitor is a 0.1 microfarad. Okay, so 8.2. We'll just see if this gives us the right thing, and then we can kind of just mess around with the values. 0.1 is 100 hertz. Okay, so we need to make it 10 hertz. Probably the best way, I think, if we just change the capacitor to a 1. Yeah, if we change the capacitor to 1 microfarad, we're multiplying by 10. That's going to change everything. 10 hertz, 52% duty cycle. That should be good enough. All right, so let's do that. And at the same time, I'm going to solder everything together. Now, the other thing, too, is that these 2 header pins are not oriented. Like, I don't know if there's a polarity for them or anything, so we'll find out. All right, I'll move my GoPro over here anyway, even though it's not the greatest, but so you don't have to stare at my back the whole time. How are we doing on time?
Maybe it'll reset. Let's see.
You're about 45 minutes left.
Great.
I think.
Okay.
Did I do that right?
Goggles, safety first. All right, so we need a 1 microfarad on there. I'm not even going to look in your parts just because it's going to take time. So I'm just going to grab from my bin.
That is absolutely fair. We included them just in case, but I was like, I think I told Tim, I was like, I bet he's going to be so organized, he'll just have one ready rather than dealing with our mess. Yeah,
I mean, this is a tantalum, so I'm not really sure. Yeah, okay, found it. Just use this one. All right, so I'm going to take off this one that's here on the board. My God, there's so much to do. Add a little extra solder just so it holds. 105.
Also, sorry, jumping in really quick, Lana Lux rated us with a party of 258 folks. Everybody that is joining right now, thank you so much. You are watching a live stream of Colonel Con, where Joe Grand, the creator of the DEF CON badge, is solving a hardware challenge that's themed for Among Us. But basically, Joe Grand has been given a series of hardware components with no knowledge about how the components are created or how they need to be connected, and is figuring out how to make everything work so that Joe Grand can escape the planet. So you are watching some live hardware hacking right now.
Thank you for watching and watching me suffer.
I think you're doing great. You're crushing it.
You can watch it's, a lot of this stuff is just time consuming of like the soldering. So I'm soldering everything down now, like I said, just to get it out of the way. And if I have to desolder something for some reason, I will, or I'll just like carry the whole thing over. So I have those two. Probably maybe a better way to do it would have been to like have a bus of power and ground and then power everything from there. But, hacksaw. So this one doesn't. This one needs some more solder on the. I got to tin these a little bit because they're kind of just stranded wire all over the place.
Just for the folks who are joining us, the main screen right now is broadcasting from a GoPro, and the GoPro is having a little bit of issue, but we are in a time constraint where there's only a limited amount of time to solve this challenge. So Joe is pushing ahead, solving the challenge and just kind of narrating as he goes. And then we are just kind of watching in Minecraft mode, if you will.
Yeah, and we're going to be switching back and forth anyway. This is just like if we have to do some close-up, something or other, we do it on here, and then I'm going to have to go back to the terminal pretty soon anyway, I think. I got to check the other clues that we had.
Absolutely.
Actually, you could always put that back on the screen too if people want to see the current state of the different stuff that we have to get working of these five modules or 6 modules. Yeah, 5 modules that we hooked up. We found a UART interface, so a very common type of like communications interface. Generally, a system's going to use that to talk to a human, of which we are. So it's like, you know, printable ASCII text and everything that we can see. Not always, but in this case, so we could actually see, and there was a boot log that said, like, you know, we had to fix certain things. All right, so everything is soldered up here, except the memory module. We have to extract this separately. I'll probably do this one next, just because it's so fun. I'm going to bring this back over to where we were sitting. And why do I feel like that sensor is going to be needing to be like flipped around or something like that? Shit. Okay, well,
that's a good intuition.
I mean, it's just like there's not much else going on there. And what was the clue for that one? For the engine module, did it just say it wasn't working? Let me scroll up on here and see.
Yeah, fortunately, we have access to the logs, and we can go back and check what the logs say.
Save the backlog on there. Crap. I thought I would be able to copy. Well, wait. Power distro. Okay, that one's damaged.
You should be able to run it again.
Oh, I'm not plugging that thing back. Okay.
Oh, you're not plugging it anymore. Sorry. Oh, duh. Yeah, you moved across the room. My bad.
Well, I think I'm just gonna. You know what? Since I'm here, I'm gonna flip it because
just get a really long cable. Just run it back. No problem.
it's either going to be flipped or like the pins are some other way going to be messed with because there's no other option. And I don't remember what the error was with that. It was saying it was doing half or something, but I'm just going to YOLO. And I remembered that it was originally facing that way. So I'll flip it around. And if I break something, I can always come back to it. This was one I was not that excited about. So
you're trying to get off the planet. If you break it, you're going to die.
That's true. I should be excited about everything. Need to survive.
See, this is one of the things I love about hacking, right? You get like your spidey sense starts tingling. You're like, oh, like this thing seems interesting. You start investigating that. But worst case, you just back out and then you go down another path. And so
that's right.
I always appreciate that idea of like, all of a sudden I feel like this is the thing that is most interesting. This is where I should be looking. And sometimes it's right, sometimes it's not. In the previous challenge with Chris, I was like, whoa, that one subroutine that had like 12 different parameters being passed in. I was like, that seems like the thing that's really interesting. And then when we looked at it, it was just printing. There was nothing exciting going on there. So, I was like, oh, okay, never mind. That's not it. And back out. And then we go look at other things.
So to try and save you some time, Joe, you might want to do some continuity testing on the engine temp one that you just flipped.
Okay.
I don't know if that's a good clue or not.
Probably not yet. I haven't even looked at the data sheet for the thing, but
well, start there. That's a good place to go too.
Yeah, I'll do. There's so much to do. I'm going to do that one later. So
we talk about this with hacking, where like a lot of it is reading documentation, right? It's boring. You don't see that in movies. You don't see like, oh, we've got 30 seconds to figure out how to get into this thing, and people are like, oh, okay, I'm just going to go look at the manual real quick. Like nobody does that in the movies, but really, it's like, oh, if I got to get into something, I want to know how it works. Like, is there a default password? And you go look at the documentation to figure out like how does it work? What's the thing?
So I plugged it in. There's an overcurrent condition. So this thing is drawing 750 milliamps, which isn't right. So I think what Tyler just said maybe is like, check the continuity. Okay. I guess I have to look at.
Tyler, you weren't trolling? I thought you were just like giving Joe a hard time.
Well, I'm trying to save him time so he doesn't have to keep soldering stuff.
No, I better look at the data sheet for that one then.
Okay, 30 minutes apparently is what I'm being told.
Yeah, check out the data sheet of that.
TMP 3602. I can read. Temperature sensor. Maybe I'll get some other stuff ready at the same time. So that. Am I allowed to physically take this thing off to get the chip map? I don't know.
With the memory module, you can do whatever you want.
Okay. Okay, so temperature sensor, 3 volts. Okay, so what he was saying is check the continuity. So I'll make sure that pins are going to the right spots. And this is the bottom view. So so if that's a bottom view and it was facing this way, pin 1 is going to be on the left, and that should be power. That's right. Pin 3 should be ground. That's not right. Pin 2 is ground. Okay, so pins 2 and 3 are swapped. Oh God. All right. So I should really have a soldering iron over here. I have one smaller one, but take my whole blob, put it back over here. Swap pins 2 and 3.
Joe, I feel like whoever designed this challenge had some idea of your like workspace layout, and they literally wanted to see you go back and forth between your benches.
I'm sure you exactly knew that.
I had nothing. I'm just a commentator.
Or Joe Fitz. Okay, so it was that way. All right, so
yeah, when I created it, and while I was doing it, I had to move a soldering iron to my computer desk, and it was a hassle running around with that rat's nest of a thing. So I'm glad to see you're enjoying it.
So you can't see this, but I flipped those 2 pins around.
Yeah, so I can kind of commentate what you got going on. So he looked at the, when he tried to power up the temperature module, he saw it was drawing a bunch of power, which is an indication that something shorted. And so he looked up the data sheet of one of the exposed part, and found that it was wired incorrectly. So now, having looked at the data sheet, he corrected it.
Okay, so I might just bring my iron over here if I have to keep doing this. All right, so I'm going to power this up, see what happens with the current now. Now it's 100 milliamps, but like a whole bunch of stuff is powering up. The display is powering up. Current is 42 degrees, or current sensor 42 degrees C, target 100 degrees C. Okay, so the temperature monitor works, fuel monitor. I'm going to have to plug this stuff in and then plug this back in. So let's get our UART back up.
Joe, how are you feeling so far? Is this fun? Is it stressful?
No, it's awesome. I was just thinking, I wish we had more time. I think it's all doable. This is all, very common type of hardware hacking process, which is cool. So, okay, so let's just reboot just to be sure. Now I don't have the connectors set up yet either, and I don't know which way those are supposed to go. So let's just, let's try which one did they say was working? The oxygen supply module, maybe? Yep, you're still breathing. Okay, that's good. So I don't know which pin is supposed to go where, so I'm just gonna try one way. See if I can do so it says I'm not connected. So let's flip those around. Maybe there's a way I could monitor those with the scope also. But let's just see. Yes. Okay. So oxygen supply is good. Status okay. Let's do our temperature sensor because that's the one we just did the soldering for. And I'll do blue and green.
Do we have a way to put his terminal back up? Sweet.
So engine temp says no. So I'm going to flip those 2 around.
Whoa. All right. So we're definitely making progress. Joe is narrating, but we didn't get the visualization of it. Now we have visualization. No, Joe, you're fine. It was just us like showing everything. Okay, okay, not there yet, but the oxygen supply is now connected and the status is okay. So we're making progress. We're almost there. We only have 4, maybe 5 more flags.
Okay. So let's double check. Communication. Oh, let's do the communication one because we just fixed that one. So that's going to be, I don't know which wires again are which. So I'm just going to plug them in one direction.
It says that the intern fixed it. So maybe try like, I don't know if it needs a password, try like SolarWinds123 or something like that.
If it needs a password. Okay.
I'm just kidding. I was making a joke about solar
Oh.
winds and how they blamed everything.
They blamed
on
their intern.
Yeah.
Okay, so the communications module and the target module are not properly communicating. They're powered.
So in an effort to give you some hints to keep things moving, I would be curious if they have to be connected in a certain way, a certain port or something.
Yeah, okay, right. Okay, so there's our 10 hertz signal. Okay, so I happen to plug in oxygen supply module is number 1. So is engine supply module going to be next to that, maybe? In order? Or am I going to have to do like a CRC32 lookup table?
You won't have to do a lookup table, but you might have to get crafty.
Too soon. Too soon.
Okay, fuel. Wait, fuel? Where the hell's fuel? I didn't even plug in the fuel, you guys.
Why not? Don't you need it?
Yeah, but it's not there. But it says
okay, then
it's
maybe you
connected,
don't
but
need
it's in a
it.
fault.
Yeah, it says yes.
yeah, but it's not. It's literally not connected.
Hmm.
So maybe I'll plug it in and just see if it.
Maybe
The intern really did do it. Let's see. Let's just check. Okay, huh. Well, now it
Whoa.
says yes and yes, and there's fault. So
run that again, SR.
Yeah, what is going on there?
now I have the fuel module and the engine temp module both plugged in. Those both say fault.
Do it one more time.
Oops, sorry.
No, you're fine. You
I
can
didn't
just.
want to do that one.
Oh, you have 3 things plugged in, right?
I have 3 things plugged in. Okay, engine temp says engine can't prime without the proper heat. Something might be wrong in the sensing circuit. Okay, so we probably have to heat that, which is why we're seeing a fault. And we're not at 100 degrees C, so I probably need hot air for that, which is also over there. Let's look
Breathe
at the
really heavy on it.
fuel module is only receiving quarter the fuel. And this is full CPU, valve. There's full CPU and valve CPU, and there's 2 sets of wires on both. So what if we just cut the wires like we're defusing a bomb or something? Because I'll probably have to fix those anyway. So right now there's 1 LED on. I'll cut the blue wire, which is the bottom one. Nothing changes.
No, you never cut the blue wire. No, I'm just kidding.
The green one.
Actually, let me, I don't know if I need to power cycle it or not before it reads it again. Let's do a SR. I didn't plug
I
it.
just
Oh, I did
came
plug it
in to say y'all have 20 minutes. Bye.
All right, so we have
All right,
25
there's still a
minutes.
fault on there.
So I'll give you some hints. So on the launch control module, there are specific ports where things have to be plugged into. So you will get a fault for if you plug the wrong thing.
Oh, okay.
into it.
That's what you're saying. Okay. So I'm gonna take those out. I'll just have to maybe I'll just do it one at a time, whatever.
That would be a fast way. There's other ways that are more elegant, but that would work quickly.
I'm not known for elegance.
Hey, as long as you get the chip fixed, it doesn't matter.
So now I have, it's still saying fuel. Okay, so that must be fuel.
What one are you plugged into?
The second one, which must be fuel because I didn't actually have fuel plugged in there.
That would be a good assumption.
So
The second one, like just to the right of oxygen?
yeah.
Yep.
Okay, that one's still faulted. That just has 1. But communication module definitely is 10 hertz. So let's just get those out of the way.
So I think we should figure out which one the communication needs to be plugged into.
So that one is engine temp is going to be the third one.
Wait, you need communication for everything to talk to itself?
Yes, this is on like some sort of shared bus or some sort of bus.
Yeah, so what he's figured out is that the launch control module is connected to all the other modules, and the other modules have to report that they're happy. Otherwise, that status report doesn't show them as happy.
Right, and you need the communication to relay that status, right?
Right. And so like he was saying earlier, there's the TX and the RX. It's kind of a 50-50 shot if you get it right, but it seems like that hasn't been an issue so far. But getting the right one plugged into the right thing is becoming an issue because he has, what is it?
Yes,
4 or
okay.
5?
Whoa, communication's okay now.
Good.
Yes.
So that's good. Now we have 1, 2. So the power distribution module we still have to change. I'm saving that till the end because that's probably not going to happen. Fuel module. Okay, so these we don't know anything about the fuel module. Let's do the
So you have that fuel one snipped, right?
fuel one is snipped.
You should listen to those wires.
Ah, okay. I will listen.
Put your ear to the wire.
I was thinking of doing the memory too, because maybe if we extract the memory, there could be some data in there. I wonder if the memory is going to be like the launch code when everything else is set up, so we need something out of there. But there's like not really a lot of time. Okay, so I have ground set up here.
I'm going to keep giving you hints. We'll get you through this.
Okay. My probe on here. All right, so take a look at these signals.
And honestly, you should, I don't know if your oscilloscope can do serial, but you should just skip to a serial adapter.
Oh, I forgot to, it's funny, I forgot to actually, I can decode in there, but is it just transmit only or is it, let's see. It's hard to tell. Okay, I need some clips.
Going to the clips drawer.
Going to the clips drawer. Okay, so if this is a USB to serial adapter, I mean, I'm wondering though why I don't see anything on either of those. Either, right? So there's like, oh, I'm still triggering. Shoot.
I just want to say, people are begging for more time on this bomb diffusing situation.
They are
Spaceship
super about
crash,
Okay, I see some-
disaster, amazing things going on.
I see some data on here. I'm going to measure. I'll do it for as long as you let me.
Yeah, we're talking about it in sort of the organizer side of things.
Okay.
To see
So this is 9 kilohertz or something, but it's definitely sending data on this line. So I assume I'll decode it, and I can do that on my scope. Just so I don't have to keep switching back and forth.
Yeah,
Okay.
Can you send data from the scope too, or only view it?
I can only view it.
Okay.
But this looks like it's right. So this is the transmit line. It's valve 1 open. Wait. And valve 1 is open.
So yeah, so you got 4 lights on there, and what do the lights say?
Yeah, there's valve 1, valve 2, valve 3, valve 4.
And then the line sending information is only saying valve 1.
Right. So do I have to send data on each of these? These are all these are not sending, but they're all logical level high. So these could all be different receives.
So look at the two sides that are named.
Oh, valve and fuel. Wait a second.
So I would imagine that the valve computer is in charge of the valve. So we just need to tell it the right things.
Oh, valve and fuel. Okay. So if I touch those together, no.
So if you touch them together, you just reconnected what the what the fuel computer is already sending, which is only to open valve 1, which we learned isn't enough. So if we can like mimic.
Oh, that's the train. Oh, that's telling. Yeah. Okay. So that thing is telling the valves to open, and that's saying valve 1 open. Okay. So we will. But which one do we tell it? We go on the fuel side or on the?
You should tell the valve computer it should open more valves.
Valve computer. Okay. And there's 2 of those. So which pin is it?
One's TX and one's RX. If you got 50 shot.
All right, fine. All right, so I'm gonna use my probes then on TX and RX. That is hilarious.
So to answer that question of the kit, I have too many hours sunk into building these to make kits, but I will happily post like PCBs and code and sort of stuff for people if they want it.
Okay, so I'm on, you know what? Also, I need to relook at the scope and just make sure I have the data in the right way. It's VLV1-open. VLV1-open.
So he's looking at the syntax that's happening between the two microcontrollers in it. And he's seeing that one is calling for a valve to open. He just noted what that syntax was.
So I just connected TX and RX and didn't see anything. And I don't see anything this way either. But what if I just do like, it might not be responding to me because I am looking at 9,000 kilohertz, which is close enough to 96. What if I just do like VLV2-open? Oh, it worked. Okay, so there was no response back, but it was telling us, it was listening for data. Okay, VLV2 open, VLV3-open, carriage return, VLV4-open, carriage return. Okay, that's all set. I'm going to disconnect that. So fuel module should be working. I need to reconnect this launch control module thing, which I don't remember which way it was. So let's just try one direction, see what happens. Yeah, the cool thing about this USB serial adapter, most of them anyway, is like you keep your terminal open and you can just switch back and forth between stuff. All right, status. Communication, yes, okay. Fuel, yes, okay. Oxygen, yes, okay.
Fuel.
Engine temp fault. So we're gonna have to heat that. Let's see if I just hold on. Nah, that's gonna take a while. Memory and power distribution. So power distribution is that schematic, which looks like this.
Yep.
And I hate you. I hate you already. Let's do the memory. That's fun.
Go over the memory.
Okay,
so
I'll
recap what go ahead.
Yeah, I was just gonna say, here's the memory. It's covered in epoxy. I'm gonna scrape some epoxy off just to get access to the pins because there are little test points, but they're kind of small. So I'm gonna just probably solder wires directly to that chip if the epoxy is if I can get the epoxy off, and I'm gonna connect it up to my device programmer and see if we can read it. And that will be, you'll see it on the screen share.
So to recap what happened with the fuel one. So there's 2 microcontrollers in there that had a line going between the 2 that was exposed on the top. And there's 4 lights on it that say valve 1, 2, 3, and 4. And only the valve 1 was lit. So when he snipped those wires, he could listen to the communication that the one side was sending, and it was only telling the valve computer to open one set of valves. And so what Joe did is noted that syntax of how it was telling it, and then just connected up directly to the valve computer and said, open valve 1, open valve 2, open valve 3, open valve 4. And then that gave the correct status back to the launch computer.
Okay, so I just got the top of the epoxy off. I realized that I want to be able to see what the part number is, so I don't have to solder all 8 pins probably. It's probably just going to be like 3 or 4. So I got the epoxy off. I need to go use my microscope because I'm getting old. I can see this part number, which is funny because I have people do this in class. I'm like, you don't need a microscope. You can just turn it the right way and you'll see the light.
Just get younger. Make your eyesight better. Come on.
It's a 24 LC256. So that's a 256 kilobit serial double EEPROM. So 24 LC256.
Attention, kids. Attention. Here in the spaceship, I was told by the captain we got 10 more minutes. So 10 more minutes added to the total. That makes what, 20 minutes now? A little bit less than that, maybe.
Yep. So you got the part number on that, right?
Thank you,
Joe.
Good luck.
What's that?
So you got the part number off of it?
Got the part number. Yeah, we can share the screen if you want. I'm going to pull up the data sheet just to make sure. So yeah, with these types of devices, it's I²C. So you're going to need power, ground, clock, and data. So I just want to make sure I know the right pins. So we're the DIP package. We can ignore the address ones. We can ignore the right protect. So pin 4 is power. And I'm going to solder wires and just plug it directly into my device programmer. VSS, SDA is 5, SCL is 6, VCC is 8. Okay, so I'm going to switch over here. Should I bother bringing the GoPro?
You're good. Just okay. So what he did is he scratched the epoxy off of the memory module, because with the epoxy on there, he couldn't read any of the part numbers, and so it would just be a complete guess of how to connect to it. So he scratched the epoxy off, put it under the microscope, got the part number, and then looked up the data sheet. And I don't remember who told me this, but someone said that like electronics are just Legos, where the components are the bricks and the data sheets are the instructions. But it's totally true. And so he looked up the data sheet for that part, and it tells you everything about it, how to connect to it. And so now he's over there soldering on some jumpers to the correct pins. so that he can interact with it.
Yeah,
Yeah,
I always.
those little solder connections are really small too, but those solder pads. But I should make it work. I have some gigantic wire, but it should be okay.
So I wasn't too nice. I didn't put test pads
Yeah, it
per
wasn't
se.
super easy.
I put vias on there, and the thought with that was, sometimes if there's a chip that's epoxied or whatever, you'll have to find where those connections like percolate up on the board somewhere else, and so it might not be crazy convenient to get access to them, and you might have to solder onto a via.
Little tiny pins. What you can also do too is scrape the epoxy off more to get access to the pins. But in this case, I'm just gonna hope these vias hold. All right, so I got one in. This is like speed hacking.
Speed soldering.
All right, so I got one, and now I got to do pin 5, 6, and 8.
How do I get a TASBot to do soldering for me? TASBot being the tool assisted speed run.
That'd be nice.
Yeah, right. Just be like, TASBot, please do the thing, and it's just like figures out everything and does it for me.
All right, I got 5, 6, and 8 coming.
So kind of recap, we got the oxygen one working, you got the fuel one working, you got the comms one working, you're working on memory. Temperature, you have a guess of a solution on, but you haven't tried heating it up to know for sure.
That's right. Yeah, temperature was the one with, or no, the power distro module. Yeah, temperature, I think we just have to heat it up because it's showing 28 Celsius and it has to go to 100. Okay, so here's the memory module. It's wired up. I am going to use my device programmer, which is this device here. I have to run Windows. Okay, I'm going to stop sharing my screen for a second. And I'm going to launch VMware. Make sure I'm not sharing.
Yep, we don't got you on screen.
Sharing. Okay.
And for the temperature one, we can just like put it in the microwave for 30 seconds. Should be good.
Yeah.
Yeah. You want to make sure you're stranded on the planet, you can do that.
Okay, I'm going to share my screen again. Oh wait, can you share my screen or no, I got to do it again. Hold on.
If you share it, we can display it.
Okay. It's share screen. Now I'm running VM and GoPro. This will be interesting. Oops, don't share. That's okay. You don't need that one. We need this one. Okay, so let's make sure our device programmer is connected. Device programmer is connected. So this is a Zeltec. This is Windows 7, by the way. It's a Zeltec SP51S device programmer that's designed to read and write different types of memories. It just happens that it supports this 24LC256 along with a million other things. So what I'm going to do is just, I don't know if you can see it on the camera here, is I'm just going to wire one-to-one the connections on here. Usually I would use cables and stuff, as you probably figured out by now, but I'm just going to hack it together. So I got to be over here. So pin 4 is here, and I have it's a socket, so I can just put this in and then close the socket and it will hold the wires in place. So there's 5, that's 5, 6, 8, and hope the solder connections hold. Okay, that's in.
Everybody cross your fingers.
Assuming I wired it up properly, we can switch back over to my screen share.
We're seeing double of you because the GoPro's lagging.
Oh,
there
funny.
you go.
Double, okay. So I'm going to select the device, which is, it's a 24LC256 microchip in a dip. So now I can just read, make sure I don't do erase. So let's read the device and see what it says, I guess. 4-pin contact, pin 7. Ignore because we don't need pin 7. Oh. Yeah, so we didn't even, so we're basically, the device programmer was powering the chip for us since we're doing it out of circuit. It looks like it was a pin check error. We ignored it. We'll read it anyway and see if there's data in it. Launch code, let's pop this kernel. I knew it.
Yes.
Okay. Let's pop this kernel con. Okay. All right.
Nice.
So that one's done. Now, Can you unshare my screen for a second? Because I'm going to close it up and just see what else we have to do. Okay. I just want to make sure nothing pops up on my screen.
So
I mean, pretty much everything is closed anyway. So all we have is the power distribution module and the temperature sensor. I'm guessing that we're going to need to heat that up. So I'm actually going to go run to the shed and get a butane torch because I don't have my hot air is over here. So I'll be right back. You guys like maybe Int80 can do a rap or something.
No.
You don't want me to do it live?
I can't mess with these CPO
Y'all have
tools,
no
man.
idea this. Y'all have no idea the struggle it is to do the cam controlling for Joe Gray.
He's got 2 cameras and a screen share all over.
Jesus, he's fast. Oh my god.
We have a player on UHC.
Share the screen, share the thing, share him, share all of this. Oh my god, what's going on?
Yeah, our player Salesian that plays on UHC is like that.
Okay, so I have butane torch. Maybe we'll just test it before. Let's go back to
the GoPro cam, maybe.
Yeah, and you can share my screen also because you can't really see on the GoPro, but there is a display on here that is saying the temperature. So I'm gonna very carefully from far away heat it up and see if it does it heat.
Yep, right, and also like how significant does the temperature change have to be?
So that little screen.
It says target of 100, and it's at 74, 77, 83, 88, 95. Oh, temperature prime, status okay.
Boom.
Now it's good.
Yes.
Okay, so all we need is the power distribution, which, oh my God, I don't even know what.
All right, I'll give you some fast clues on that one.
Okay, let's look this up also, just so people can see what the part is. It's a 74LV1G32. Okay, go ahead.
So there's 2 types of parts on there. That's one of them, and there's another one. I'll let you look the other one up.
The 108.
So what are those? Let's start with that.
Okay. That's the 108. Okay, so we have a 2-input OR. So
Okay.
32 is a 2-input NOR. NOR always confuses me because it's the negated version of the OR. And then you have a 2-input NAND.
It should just be an OR.
Wait, did I read that wrong?
Yeah, it's an OR.
So
it is an OR. Okay,
ground
good.
Control, here in ground control, I've got news from the crewmates. Everyone's screaming on the deck, but we're trying to make everyone, calm. The chat is going insane, and I will give you 10 more minutes.
Okay.
But that is final, y'all.
This is all we need. This is the last one, and we're off.
We are really cheering for you to survive.
Okay, so I don't know how I'm going to do this unless I draw it.
So I would say I would start tracing it like a continuity.
Okay.
And start from the output.
Start from the output. Okay, so
the right side.
Okay, I'm going to use a marker. Is that I can draw on this, right?
Yeah.
Okay.
Your paper.
Joe, you're not left-handed, are you?
No. Should I be?
Oh, okay, no. It's just like if you're starting from the right side, if you're left-handed, you're.
So I'm putting this on the GoPro, just like I'm moving it over, just in case you want to kind of see the GoPro. So, so the output goes to pins 1 and pins 5 of IC4, and then IC. I mean, is this supposed to be? So it's going to have to be serial. Right, it's gonna have to be serial UART to communicate to that thing. I think. I don't know. What the? Okay, so that's power. So this one's power. Pins 4 is the output of.
So I will say it's not cycling around the UART. It's just got to be put in the right state.
Okay, on the input. Maybe. So pin 3 is okay, and so I see power. Oh my God, this is the worst. It's like you knew that I hated digital logic.
Okay, so I would multimeter continuity and just start comparing what the output pins on the right side of the board, how that compares to the schematic.
Got it.
And the
Okay.
schematic is what you're trying to make
I see
it,
what you're
right?
saying. Okay. All right.
Yeah. So they recreated the board from a schematic, and they think they
and did
messed
it
it up.
wrong. Did it wrong because the intern. Okay, so maybe I'll have to patch something or something like that. Okay, so let's see. So JP2 pin 1 is supposed to go to pin 4, which crap. I really want to make this thing work. Got to pull up the part.
Hey, Joe, can you rotate your cam back just a little bit more towards your workbench to get a little more surface exposure into the camera lens?
Which one? This one?
Yes, your GoPro.
Oh.
Pivot it just to the right here.
Yeah, there you go.
Yeah, okay. All right, so so I'm just looking at the data sheet here. I need to look at the, okay, so we're looking at this type of package, the SOT 353. So pin 4 is Y, so that's the output. Wait a second. Well, it goes to 2 different places. Wait. Is power and ground going to the same thing? Do I just have to cut traces on this thing?
So you'll have to cut traces and add jumpers to make it match.
Okay, so
I'll tell you, you need to cut 1 trace and add 2 jumpers, but I won't tell you where.
Okay, so I'm gonna think.
Unless you ask nicely.
Oh, okay, okay. So pin 1 goes to pin 4, and then pin 1 also goes to pin 5. 1, 2, 3, 4, 5. Does not go to pin 5, and then pin 5 goes to a bunch of other things. So I'm not even going to check that out. So I think pin 2. Wait, 1.
Tell me what you're thinking, and I'll tell you if it's.
I think pin
right.
1 and 5 need to be jumped.
Yes.
Okay. Jump 1 to 5. I think. Let's see. Let's check pin 2. Pin 2 is nothing. Pin 3 is supposed to go all the way to.
Pin 2 is supposed to be nothing, but is it nothing?
All right, there's something there. Okay, so yeah,
So
okay, so cut pin 2. And then that means there's going to be 1 more jumper. Does it have anything to do with the input side or no?
No, just keep tracing from the output.
Okay, so then pin 3 goes to IC2 pin 4, which is labeled U2. So that's pin 3, and then it also needs to go to U4 pin 1, which it does not. U4 pin 1 is maybe it. 1, 2, 3, and then it also needs to go to U3 pin 4.
I lost track. What pin are you on for the output? On 3?
I'm on pin 3, and it should be going to a bunch of different things.
It should be going to IC2 4.
IC2 4. I saw that one, but I didn't see IC3 1. Wait, IC3.
You saw it connected to IC2 4?
IC2 4. Yeah, right here.
Really?
Hear it? Oh, wait. No, that's U2. Yeah, it's connected to both.
Pin 3 is one that needs to be jumped.
Pin 3 needs to be jumped. And where does that need to be jumped to?
So on your schematic, it shows that it should be jumped. Pin 3 should be connected to IC2 4.
It is.
Are you sure?
Yeah, you hear it? Oh, it's a little high. Okay, so it's maybe not totally connected. Yeah, okay. But something's connected there for sure.
Oh, there's something connected, but is it?
Right.
Okay,
So
it's got some resistance. Okay, so IC2 pin 4. Right? Pin 3 to IC. Is that the one? So I can go do it?
So yeah, I would jump. What do you got? What's on your list to do right now? I'll tell you if it's right.
Cut
Good
pin
question.
2.
Yes.
Jump pins 1 to 5.
Yes.
And then take pin 3 to IC2 pin 4.
That sounds pretty good.
Okay, so I'm going to cut pin 2 first, which is, I hope I'm doing this the right way on here. I'm just going to cut the trace.
Yeah, be careful. There's another trace that's pretty close to it.
Well, there's one right on top, right?
Yeah, there's one right on top of it. So just get
Yeah.
the bottom one.
Okay, so I just cut pin 2, I think. Let's verify that with the multimeter. Oh, we're so close. How are we doing on time?
Yeah,
Okay.
like 9 minutes, and that's not going into our extension. So we're good.
Okay.
We got this.
So I think pin 2 is cut, so I need to jump I need to do 2 jumpers. Oh my god, that means I need to bring the freaking soldering iron over here.
Oh, you soldered it to the LCM already, huh? The launch control module.
Everything is soldered. Everything. Oh, right.
Don't
Okay.
worry, Joe. You're our best engineer here, and ground control is on your side. So don't worry.
Okay. I will. Yeah, I already soldered it. So let's see.
Remember that first statement from the challenge description. You are the universe's best hacker. You wrote that down in your notes.
Where's my other soldering iron?
So you should open bag 5.
Everything. I'm bringing it all over. I'm bringing it all over.
Joe, open bag 5. It can help you.
Oh, thank you. Okay. I was just going to bring it all over. It might be easier.
It has the tool you need.
It has the soldering iron.
There's a soldering iron in bag 5. Send me a bag 5. No, I'm just kidding. I already have soldering iron.
I don't think you want what he's going to find in there.
Is it like a Radio Shack something or other? Let's see. Ah, look at that. A gorgeous 30-watt soldering iron. That's awesome. Hey, that's like just the one like I used in that video. Okay, so this is how we're going to do it. 30-watt soldering iron.
So let me tell you the story about that one. That is a search on Amazon for soldering iron, and then sort by lowest price. And I found that beauty that somebody was selling used, and the description said the tip's a little burnt, but it's still good.
It doesn't reach.
So I bought it immediately.
Mine doesn't reach. I'm disconnecting everything.
Do you have a extension cable, extension cord?
Yeah, in my shed.
All right, back to the shed.
All right,
bring another butane torch just in case.
I have that too. I'm keeping it.
You can go. You can go. I won't count that time that you.
I'll bring my solder. Thank you. I'll bring my solder. Got my cutters. All right. I'm gonna get the extension cord, and we're gonna fix this ship.
So close.
Oh my gosh! What do we do to fill the time?
I don't know.
Oh Jesus! Just let me breathe for like 1 minute.
Okay, let me come up with some rhymes off the top of my head. It's a freestyle about Joe going to his shed. What he had to get before was a butane torch. Now he's going back for more to bring it up on the score. It's the freestyle flow. I haven't done it in a while. It's been a minute, and I do it with a smile. Either way, we got it going on. We're burning on because we're right here at Hack Live with Colonel Khan. How we did it on the live stream. It's my dream. Joe Grand's back live on the scene.
Oh!
Yeah!
All right.
Oh, yeah.
Iron is in with the extension cord.
Yes.
I hope it heats up.
Well, I got to strip the wires anyway, so I'm just going to let this sit. I need to strip 2 wires. I think I'm going to use...
The spare parts kit had some small wires in it if you need them.
Yeah, I'm going to use probably just wire wrap wire, which is smaller. Where is my... Oh, I'm out of breath. Okay.
You're getting your steps in today. You didn't realize you'd be running all over.
Actually, no, you know what? I was going to use the wire wrap wire, but I'll just use what I have right in front of me, which is just a regular wire. And I'll cut that, strip it, and then we are going to be off to the races. Yeah, that iron is heating up. It smells. Whew.
Well, the tip's a little burnt.
They were using lead-based solder, that's for sure.
I printed off the description of it and put it in its little bag. So if you want to enjoy this,
okay,
yeah.
Let's see.
It should be in there at least.
Yeah, here it is. $4.99 delivery, 33% positive, 30-watt iron. Great, acceptable condition. I guess if the solder melts, then it works. If it electrocutes me, not so good. It is. I
don't know if it's gonna tin. When I looked at it, it looked like somebody he said the tip was burnt in the ad, and then when it arrived, it looked like he sanded it to try and make it not look so burnt.
It's hot. It's not that hot.
Ouch! Like six out of 10, or what are we talking?
I can
Wait,
touch
did
it.
you touch?
It's like a 2. It's like a 2 out of 10.
Oh no.
All right, fail. I'm moving it all over.
Okay.
I don't have to disconnect anything other than the UART, so it's not really a big deal.
Did you try putting the soldering iron in the microwave? I heard that heats things up.
Yeah. Okay,
I
power's
think the only thing
disconnecting.
you'll have to do is reheat the temperature module. But other than that, as long as you keep everything connected, you'll be good.
Well, yeah, and I just have that's the only one I need to do, and everything else can stay plugged in. So bringing this over, I'm not going to move the camera because I don't want to waste time.
You're good. We're so close.
Okay, so now I'm going to. Oh, this is so cool. All right, I got to get my wires. 2 of those. My desk hasn't looked this messy in a long time. This is good. So I'm going to jump pins 1 and 5.
Somebody said to heat the soldering iron with the torch.
I could probably just solder with the torch, but I don't want to take the risk of messing something else up.
That would be the most amazing finish to a hardware CTF ever.
All right, pin 1 is on. 1, 2, 3, 4, 5.
You're putting 5 to
Putting 5 to
IC2
1.
pin 4.
No,
Or, sorry,
jumping,
sorry, 5 to 1. Yes, you're right.
jumping 5 to 1. And then I'm so glad I didn't have to work out the logic of that schematic. And then pin 3 to IC2 pin 4, because there was some sort of resistance there, and it needed to be a pure jump. So let's do pin 3. I'll take a picture of this whole setup too when I'm done. I'll post it on Twitter so everyone can see the mess. Okay, so IC2 pin 4. So pin 4 is going to be the bottom one on here. So I'm going to add some solder.
I'm double checking my copy of the schematic to make sure it's
Yeah,
right.
because I don't want to bring it over again. Okay,
Yeah.
so those are in. So if that's right, I'm going to bring it over.
Yeah, so you cut 2, you jumped 1 to 5, and then you made 3 go to IC2 pin 4.
Yes.
Should be good.
All right. We're getting close. Here we go. Hope nothing breaks
drop
on the
it.
way. I love the launch code was in the memory too.
All right,
Crazy.
everybody, hold your breath for this.
Okay, this is it. So I'm going to plug everything back in. And I might have to heat up that temperature monitor again. I will have to plug in the power distribution module also to the launch controller. Let's see. Let's get this going. We can share my screen again if you aren't already.
You're probably going to have to do fuel again, too, because that'll be reset. The valve 1, valve 2, valve 3.
Yeah, okay.
Tick, tock, tick, tock.
Okay, yep, temperature is down. Fuel, there's nothing now because we
Reset it.
disconnected it.
So you have to tell it again. The valve's got to open.
Okay, so this is it. So power distribution module. Actually, let's do a status report. Plug in the power distribution module. We don't know where it's supposed to go. I'm just gonna randomly try.
I would
nothing.
try the bottom far right one.
Okay. Power distro. Okay.
Boom.
All right, so let's get the fuel module working. Of course, I disconnected it, so I don't remember which was transmit and receive, but that's okay. Easy enough.
50-50 shot.
50-50 shot. Got to disconnect. Yeah, so the temperature module we have to reheat also. It's in a volatile storage.
Yep. So since we rebooted, we lost all the state of all that stuff.
Okay, so that's going to be. I need my notes. Valve 1 open, assuming I'm in the right spot. Yep. Okay. Nice. Valve 2 open. Now I'm just typing VLV3- open, just like we decoded on that other line. VLV4- open.
You can see the lights coming on in the
The
GoPro
lights
camera.
coming on.
Yeah.
Okay, so now I need to switch back over to the serial terminal.
Did you heat it already? The temperature one? or
No, not yet.
Upcoming.
I just want to. Okay, so engine temp, last one. Let's heat it.
Keep the notes away from the torch.
Oh, good idea. Thank you.
Safety third.
Okay, so torch is on. I'm melting the ABS, by the way. of the holder. We're 48, 53, 67, 72, 82. Temperature prime, status okay. Ready? Here we go.
See that terminal.
Everything's
Show
ready.
that screen. Let's do it.
Wait, what was it? Help? Okay,
Launch.
so we don't need the log. Launch. Enter launch code.
Oh no, what's the launch code?
Let's pop this.
You should do it in a text pad first because it's
wait.
gonna
Oh shoot.
type it into like a text pad and then copy
Is
it in.
Okay. Let's pop. So it's expecting it in some amount of time. Maybe.
Or maybe
Let's
in
pop
one
this
shot.
kernel.
Yep, that looks good.
Okay. Launch. You guys ready?
Yes.
Ready to launch? Okay. Here we go.
TikTok.
Ready? Who's going to count
3,
down? 10, 9, 8, 7,
7,
6,
6, 5,
5,
4,
4,
3.
3, 2,
15.
1, launch. 10. Oh, now it's going to count.
Oh.
8, 7, 6, 5, 4, 3,
3,
2,
2, 1.
1. Lift
Blast
off.
off. Yes.
Hack the universe.
That was amazing.
Holy
You did
Oh
it.
my God, that was so cool.
Wow.
Congratulations.
That was awesome. That was fun.
Yes!
Speed run.
Thank you.
Oh
Now
my
everyone knows
God.
if you ever have to fix your spaceship, this is what you do.
Now you know how.
You become Joe Grand.
That was awesome. Thank you for the support and the cheering in the chat, which I'll look through later, and the help from Tyler, which definitely helped, and of course Joe Fitz and everybody. That was killer. And again, I'll take a picture so you can actually see what it looks like now. Maybe I'll put the soldering iron up there, even though I didn't use it because it was hilarious.
If you had more time, you would have totally solved it. You had it all. You knew what to do. It was just putting in the time to figure it out.
Yeah, I mean that's the thing is, like I said at the beginning, like, and as we saw throughout the day, like hacking is not like you see in the movies, right? It's hard, and like a lot of times, I'm working on a project now that I've been doing it for 6 weeks and going down all these different paths. But then you pop something, you're like, oh my God, right? And then you take the next step and you do it again. So it's that kind of like adrenaline rush of something like this, which is what makes hacking so awesome, right? And it's like what makes this stuff so cool. So
it is the greatest roller coaster ride. You're like working, and then eventually you solve the thing. And you're like, I'm the greatest. And then all of a sudden your next challenge is just like, like I'm lost. And
and then you're like, am I worthy anymore?
Yep.
Yeah.
But you're always worthy. Everybody can do this. It's amazing. And having that experience is so wonderful. Joe, thank you so much for running through this with us. This has been incredible. I learned a ton. And I am excited to do more hardware hacking stuff.
Awesome. Yeah. And that's the point, right? Is like get people excited, and you really can, anybody really can do this stuff. You get the right tools and you just start poking around and you get it. So yeah, thank you again.
Absolutely. I'm glad you liked it. I hope you got a chance to just rush through it, and I hope everyone picked up something new.
And just as we gave props to Cyphertext on the previous challenge, Tyler and Joe Fitz, amazing work on this challenge as well. Y'all did amazing. That was so cool.
Thank you.
Hell yeah.
That was
So I think
beautiful, just beautiful.
So I think we're going to do a Q&A.
Yep,
Yes,
we're
we
going to have
are.
I think the plan is to have a panel with all of the hackers from Hack Live, from KernelCon's Hack Live, and then everybody gets to basically do an AMA with them.
Yeah, so Joe, if you just want to hang out. But I think before that, we have something that we would like to announce for next year, if Issa, you want to play the video. Sorry, I might have said it too soon.